Hi everyone, let's continue with our study of even and odd functions. This will help us a lot. The fact that linear combinations of even functions are even and linear combinations of odd functions are odd. What's an example of a linear combination of two functions f and g? Here's an example. 2 times f plus 5 times g. That's an example of a linear combination of f and g. Anytime you have a number times f plus a number times g, that function will be a linear combination of f and g. In fact, the zero function is always a linear combination. Now, if f and g are both even functions, then 2f plus 5g will be even. If f and g are both odd functions, then 2f plus 5g will be odd. In particular, the sum or difference of even functions will be even. The sum or difference of odd functions will be odd. A constant multiple of an even function will be even. And a constant multiple of an odd function will be odd. So for example, well, first off, here's a proof showing that the sum of two odd functions is also odd. Don't freak out about this, but here's a proof. Let's say that we consider the graphs of y equals x and y equals x cubed. These both represent odd functions. Their sum, given by the rule x plus x cubed, will also represent an odd function. You can get this from a table of values or from a graph. In blue, we have the graph of y equals x. In red, we have the graph of y equals x cubed. In brown, we have the graph of y equals x plus x cubed. The odd property, where we have symmetry about the origin, is maintained. The blue, red, and brown graphs are all symmetric about the origin. All three of these are odd functions. So for example, if we take y equals x cubed, this graph is an odd graph. I could multiply it by 2, by 3, by -3. All these graphs will be symmetric about the origin. These all represent odd functions. I can multiply x cubed by any real number, and I get an odd function, even the zero function. If I have y equals x plus x cubed, that's also an odd function. We have symmetry about the origin. In fact, I could go y equals cx plus dx cubed, and I can slide over real values for c and d. So c could be various values, d could be various values, and we retain that odd property. The graphs are still symmetric about the origin. So again, any number times x plus any number times x cubed, that's going to represent an odd function. A number times an odd function plus a number times an odd function, that's going to get us an odd function. Linear combinations of odd functions are odd. Likewise, linear combinations of even functions are even. Let's do cx squared plus dx to the fourth. Get these W-type graphs. Even, symmetric about the y-axis. Next up, we have some easy rules for figuring out whether polynomial functions are even, odd, or neither.